Ladies and gentlemen, as the conference is about to commence, we kindly request that you take your seats properly. Your cooperation is finally and settling into your seats is greatly appreciated. Thank you. 各位同学，现在要坐好，然后你们手机就是要关静音。我们要准备开始了。那因为他们有线上直播，所以等一下手机不要响，好不好？手机不要响，可以做到吗？可以做到的举右。都有做到了哈。Selamat pagi, nama saya Linda Lin. Senang bertemu Anda. First of all, we are grateful to present you a Taiwanese cultural dance performance from our Kunshan alumni magical group, BO. Is going to show us the opera face changing. Let's give the pose to welcome them.
新鲜。老头一转，面孔说的不变，今一他，我顺其成全，名扬四海，赞叹参去变变，绝妙精彩，更替他传在四川。变变，变变，变变。看看看，技术不快如电，快如电。变变变，好潇洒，好浪漫。说是不知，那是不瞒，男子不会活，你这不难。30岁一人看近看，前看后看，左看慢看，左看右看，上看下看，环看四看，硬是好耍又新鲜。
Let's give one more round of applause to the bill. Ladies and gentlemen and honored guests, welcome to the International Conference on Applied Science, Technology and Engineering, International Conference on Economics, Business, Social and Humanity 2025. Let's begin the conference. Today's event will be hosted by me, Linda Lim from Kunshan University, Taiwan. This year's international conference, Universitas Karumanagawa cooperates with Kunshan University and INTEC International University to bring together professionals from different countries to share ideas and exchange knowledge in economics, business, social science, and humanities. This conference provides a platform for high-level international discussion and presentation on recent advances and new applications in these fields. Before we deliver into the enriched discussion and presentation ahead, let us take a moment to recognize the presenter of our distinguished guests and the distinguished who grace us with their wisdom and experiences. Your presence truly enrich this gathering. First of all, it is an honor to introduce the distinguished guests From INTIC, Director of Postgraduate Studies Center, INTIC International University, Professor Dr. Chen Zhongkit. Please stand up. Thank you. No, it's introduction. And the Kunsan University Vice President from Economic and Dean Research and Development of Kunsan University, Dr. Hong Shengxiong. And also the Director from Business Administration, Dr. Mark Lu. And for the Universitas Tarumanagarawa, Indonesia, we would like to give the most welcome to our Rector of Universitas Tarumanagarawa, Professor Dr. Aman and the Director of Research and Community Engage Institute, Dr. Hattie. And also the Board of Commitment of the ICASTE and ICEBSH. We would also like to extend our sincere appreciation for the attending of all scholars, lecturers, and students at today's conference. Your participation is very important and for the success of this conference. Last but not least, as we embark on this collaboration journey, let us extend our gratitude to the organizing committee and the volunteers and everyone who has contributed their time and effort to make this conference possible. Your dedication and commitment are truly important for this conference. And the following, we are going to start the opening speech. On this section, we extend a speech from our Vice President from Kunsan University. Let's give the pause to Dr. Hou Shengxiong.
Good morning, distinguished guests, ladies and gentlemen. Only welcome to Kunsan University. It is my great pleasure to welcome you to the 2025 International Conference on Economics, Business, Social, and Humanities, ICEBSH, and the International Conference on Applied Science, Technology, and Engineering, ICASTE, jointly organized by University Tarumanagarawa Winter from Indonesia, Kunsan University from Taiwan, and the International University from Malaysia. This year's theme, accelerating global sustainable development through higher education, highlights the critical role of higher education institutions in shaping a more sustainable and interconnected world. As drivers of innovation, universities are uniquely positioned to address the pressing global challenges outlined in the Sustainable Development Goals, SDGs, through research and technology. By bringing together ICBSH and IASTE, this event serves as a dynamic platform for interdisciplinary collaboration, allowing experts from diverse fields, ranging from economics and business to science and engineering, to exchange ideas and explore innovative solutions for a better future. The diversity of our participants and the speakers brings a wealth of perspectives which we believe will offer profound insights into the transformative potential for collaboration in research and technological advancement. I sincerely thank Winter Foundation Chairman, Professor Dr. Aliwan Gunati, and Rector, Professor Dr. Ahmed Sudido, for organizing this event and supporting collaboration between Queensland University and Indonesian universities. I also extend my gratitude to the International University for co-hosting this conference, promoting academic excellence and fostering international cooperation. Looking forward, Queensland University is committed to fostering stronger partnerships with academic institutions through a wide range of initiatives, including academic visits, joint lecturing programs, collaborative research, academic resource sharing, elite student exchanges, and more. I would also like to thank all of our distinguished speakers for their valuable contributions and express my deep appreciation to the organizing committee for their dedication and tireless efforts in making this conference a success. Let us move forward together in the spirit of collaboration, innovation, and global impact. And I wish you have a productive and inspiring conference. Thank you.
And next, we are going to invite University Talu Managala, the rector, Aman Stilo. Let's give the pause. Thank you.
Good morning, Chong An. Selamat pagi. As a rector of Universitas Tarumanegara, it is with a great pleasure and immense gratitude that I extend a warm welcome to all of you today. First and foremost, I would like to express my sincere appreciation to the Honorable Vice President of Queensland University, Professor Dr. Ho, and your esteemed team. Your commitment to academic collaboration and cultural exchange is truly admirable and sets of a meaningful precedent for educational partnership. Together, we have the unique opportunity to follow a path toward share knowledge and mutual growth. I would also like to extend my heartfelt thanks to the Honorable Chairman of the Tarumanegara Foundation, Prof. Aryawan. Your vision and answering support have been instrumental in advances our mission at Universitas Tarumanegara. The foundation serves as a beacon to hope and inspiration, enabling us to pursue excellences in education and community engagement. It is both a privilege and pleasure to stand before you today at this esteemed international conference held at Kunsan University 60-year anniversary in the vibrant city of Tainan, Taiwan. I would like to extend my heartfelt gratitude to your hosts for their warm welcome and for organizing an event that brings together thought leaders dedicated to one of the most pressing challenges of our times, sustainable development. The theme of our gathering, accelerating global sustainable development through higher education, reasonable deeply with the core mission of our institution of educate, innovate, and inspiring future generation to create a more equitable and sustainable world. As we embark on this crucial dialogue, let us reflect of the transformative development, transformative power of higher education. Universities have long been catalysis for a change, shaping mean and equipping a student with the knowledge and tools and address complex global issues. The three themes of unprecedented environmental, economic, and social challenges, our role has become even more critical. By integrating sustainability into our curriculum, research and practices higher education can lead the way in cultivating innovation, solution, and fostering of culture of responsibility and resilience. Over the next few days, invite is of you of engage actively in our discussion. Together we have the opportunity to share successful strategies, explore partnership, and generate new ideas that can propel our effort forward. Let us leverage our collective expertise and experience to accelerate the progress towards sustainable future. In closing, I am excited about the insight that will emerge for our conversation here at Kunsan University. Let us embrace this opportunity to collaborate, inspiring, and ignite the vision for sustainability development within our academic institution and beyond. Thank you, terima kasih, season.
Please stay on the stage. And now we would like to invite our co-host to receive the thank you certificate from UNTA. The Vice President Ho Sheng-xiong and Dr. Chen Chong-kit, please on the stage. Let's give pause to our cooperation, and we would like this cooperation keep going for the further future. Let's give the pause. Thank you very much. We are going to start our agenda, including the following section: 3 keynote speech by Dr. Chen-Lin Zhang, Kunshan University, Tainan, Taiwan. Please wave to the audience. And next, Dr. Chen Chong-Kit, Intik International University, Malaysia. And then it's Dr. Ariawa, Universitas Tarumanagara, and Jakarta, Indonesia, and he will come soon. This session will be led by our moderator, Dr. Oscar Lee from Kunshan University, Tainan, Taiwan. Let's welcome Dr. Oscar.
Okay, we don't have a break, okay? So let's continue, okay? Students, the next following section is very important for you, okay? Because we are going to invite 3 well-known outstanding guest speakers to deliver the speech about the topic accelerating global sustainable development through the higher education, okay? So please don't be falling asleep. Okay. Ladies and gentlemen, today we are very honored to invite the 3 outstanding professors to deliver the speech. And the following process, we are going to let the speaker deliver the speech in 20 minutes. After that, we have a Q&A section, okay? So the first, okay, our first keynote speaker, Professor Chen-Lin Zhang. Okay, he is from the Kunshan University, and let's take a look at his background. Professor Chen-Lin Zhang is a pioneer academic technologist at Kunshan University, where he serves in the Department of Electronic Engineering. His diverse expertise spans electronic engineering, media arts. Oh, okay, that's very interdisciplinary, okay? And motion pictures, reflecting a unique interdisciplinary approach to innovation and education. Okay. Okay, I don't waste the time. Let's give him a big hand to welcome Dr. Chen-Lin Zhang. Okay.
Okay, thanks, Oscar. Okay, it's my honor to be here to present some of our work. Okay, during recent year in area of the virtual. Virtual AI training education. Okay, next, please. No, previous one. Okay, next. Okay, next. Okay. Okay. The Product Development Center is one of the 40 research and technology developing centers supported by the Ministry of Education since 2006. Okay, and there's a few centers still operation right now. Okay, so as we have a strong demonstrate our technology and the application is suitable and could be in the future. In the past, we usually say the knowledge is power, but the time have changed. Due to the machine learning, deep learning, AI, okay, they become to know is power. But maybe in the near future, the hearing will be the power due to the AI way listening for us and reminding us what we have heard. Okay, so the virtual and the physical integration is very become increasingly important. Okay, next, please. The sleeper movie, The Real Player One. Okay, would you please play the movie here? Okay. No, this one here. Yeah, the movie. They could play the movie here. Okay, they present the future distribution of the real virtual reality and we commonly refer to the metaverse. Sorry for. Okay, usually what we hear, the virtual reality, augmented reality, or mixed reality. Okay, or even right now we talk about XR. Okay, those kind of virtual and the real integration is embodied into the blurry area. Okay, and even for now, we have here some of like a Microsoft HoloLens. Okay, they provide the augmented reality that could embody inside the STEM technology. Okay, so bring out a new future of the virtual and real integration application. Okay, we just take a short look of the movie, okay? This is a science fiction movie, but I think that's a very important the movie to talk about the metaverse or the real or the virtual reality. Okay, that means you have a day on the real world and you pay on the virtual world. Okay, you gain the money in the virtual world and to pay your day in the real world.
All of you now because our future's being
And
threatened.
also they show some of the idea of why we have to use those kind of technology in our future life.
much bigger than myself. I found my friends.
Due to a time consuming, we just skip to the next slide. Next, please.
And now people have lost their lives.
Next, please. Next, please. Yeah, just skip. Okay, in here is the second example to talk about use Microsoft HoloLens to show the mixed reality in the future work.
She has to set up the space for
There's
a product
joint
unveil
design
for a group of
in
clients.
the remote or in the
Enter Microsoft
on-site.
HoloLens,
Okay, so
the world's
when you
first
wear the HoloLens,
untethered
you could bring the
holographic
virtual
computer.
image into the
The
real
device
world.
maps the room in
Okay,
order to
and you could
construct a
join
digital map of the
project
space,
with the different
allowing
people.
Penny to fill the room with holograms. What you see here is next-generation hand tracking. Penny moves the holograms throughout the room in real time and space. The boxes react using physics-based simulations, just like they would in the real physical world.
Sorry, Penny. This may be a bad time, but the client is on an earlier flight.
We're so not ready.
Should we start to panic?
Not yet. Just bring the team in, please.
Windows brings spatial sound, articulated hand tracking, and Samir's own hands into VR.
I can see you're hard at work, Samir, but Penny needs your help.
Yeah, sure thing. Just let me check out this bunker real quick.
Samir, the client is on...
As per usual, your sense of timing is just awesome.
Kai-san, Penny が呼んでいますけど。
今すぐ行くって伝えて。
Kai joins the conversation as a hologram. Samir also appears as a 3D avatar, which he scanned himself using his phone.
Cute.
I try. So, how's it coming?
It's not. This is the flagship store. It's gotta be unforgettable.
Yeah, not exactly blowing my hair back.
Yeah, the space is driving me nuts.
All right, how about a change of scenery?
Welcome to Think Club.
Imagine the web of the future, where you can draw inspiration from the cloud in 3 dimensions and all around you.
Some inspiration, please. Namaste.
These bots help them interface with businesses. This one helps them find amazing 3D assets.
Inspiration comes from the most unfamiliar places. I meet you, you are now me.
Kai uses a pen and Samir uses a specialized controller in order for them both to manipulate and design the 3D creation. The team forgets that they are not together physically as they continue collaborating on the design. Penny picks up the eyedropper to grab a colour from the physical ceiling in order to make things feel more anchored. Through the conversational bot, we see a real-time translation of what Penny's client is saying.
Impressive.
Okay, next, please. Okay, here is something related to the VR, AR, MR. Okay, that means we have a real environment and the virtual environment and mixed reality. Okay, next, please. Okay, so would you just play it? Okay. So in the left-hand side is our APDC Open Lab. We use a remote control to use CMOS camera to far remote control to modulate the 3D data 3D printing. Okay, on the screen you will see they have a ray virtual image. They will overlap with the real printing object. Okay, so we know the stage and the progress of the printing. On the right-hand side, okay, please, push your right-hand side, please. Yes. Okay, the right-hand side is MIT Media Lab. At the same time, they present the extra touch. Then that means they remove the virtual image to control the real movement. Okay, in the left-hand side is the real stop movement and virtual image will be following. Okay, on the right-hand side is remove the virtual image and the real stop will be moving. Okay, okay, next. Okay. Next, so, okay, just play it. Okay, both of them. Okay, so in here we present our of the first Internet of Things, that's IoT, industrial IoT. It means in here you will see the virtual image. Here is the virtual printing. Your virtual printing, usually we want to print, we call the file. Right here, directly use the image. Okay, so you could simply resize it and actually put it to command to print. Okay, and then remotely send to the real printing, and the printer will print. Okay, and here will be also the virtual image will be kinetic movement to follow the real printing. Okay, so this one is for the virtual and the real integration and through the internet in IoT. Okay, so next, please. So here is another example to show we have a demonstrate that we use this to mimic, okay, similar the Industry 4.0 product line. So you could remote control, use the virtually remote control and to send it to the automatics of the 3D printing pipeline. Okay, and the individual, we could know which one is printing during this kind of technology. Okay, so next please. Okay. And we also use the Raspberry Pi, the Gensan code production, and here please, this one here. This one is for the mixed reality graffiti of the system. This is one, usually in the US, okay, they have a 3D of the AR technology, but usually they come out the single one. And in the US, in the Japanese, they have the multi-people play interaction of the VR, but they're only for the 2D. And this one is the first example to show you have multiplayer to work on the 3D interaction. And also we use a multi-language. Okay, you could speak Mandarin, Chinese, and English. Okay, so that's the first present our work. And also we have a technology to retop the 2D information direct to the 3D mapping. Okay? So this one is for the future work, for like face tracking or lab stuff. We could use it in the future work. Okay, next please. Okay, and here is to go into the intelligence of the manufacturer. In here you will see when you visitor could find our web app. Okay, they could directly see the 70-10 degree of our automated production line. On-site, they could bring into the AR mode, okay, to the on-site training to show what the inside is of a fab. Okay, next please. Okay, and here is also the pattern with the Patiti, okay, the pattern with Patiti, they will use a technology will be similar as TSMC is using right now, okay? We use a iBeacon to push the information from the situation center. Okay, that's the remote part, and on-site, they also could do the hand-on device, okay, to mimic, okay, the on-site, the progress of this machine's doing. And because the iBeacon have a special of the IP, so they could distinguish with a different type of machine, even like I have a 7 cent type of machine inside the fab, okay, but the distinguish is different. And later on, the TSMC get an $8 billion funding from the government. They use the STEM technology to do the similar stuff, okay? But we are cheaper because we don't have that kind of money to develop it, okay? But later on, I show some of our progress using the Microsoft HoloLens and STEM technology. Next, please. Okay, and here, would you just play it? Okay, this is another example of a virtual and the real integration. And in our lab, we use a four lamp, okay, assembling teaching operation. Okay, here you can see here there's a virtual image. Okay, that could show how to operate the procedure. And when you open it and you follow the real hand, you will follow the direction. Okay, this is one for the teaching mode. Okay, and the checklist when we mark, then to show you already have done this step. And when we remove the virtual image, become the test mode. Okay, they still following your movement. And they also have the check mark here. Okay, so they knew you are doing it correctly or not. Okay, this is work in the fab, also in the 4th floor on the E1 building in our campus. Okay, so next please. And here is, I think it's a big project working with China Airline. This is for the Airbus SEA330 repairing. Would you play this movie here? No, play this one. Okay. Okay, here we will show of the engine. Okay, how to show the replace engine. Okay, the work that we play into the system here. Okay, so they bring the virtual of the engine. Okay, visual engine will bring inside this area, and they will have the mentor and the student mode. Okay, so they could surrounding to see the engine, and also could have a fundamental moon that will show how to replace the engine. Okay, so also the same thing here. Maybe need to take a couple of minutes. Okay, so it's okay. So even for this kind of situation, we build a 1-to-1 ratio of the virtual airplane. Okay, will be overlap. Okay, with of the real plane, real A330 airplane. Okay, so they could fix virtually or real airplane. Okay, so this means they could remote, like I have several, usually the airplane, they have a technician on board, okay, when they're outside the country and maybe they couldn't fix it, so they could fix the real airplane and remote with the, okay, virtual plane on the field, okay, so they could to teach each other here, so you will see. And the difference between the VR, usually VR, we are staying here and turning the image, okay? But this one is for the augmented reality. That means your engine is here, but you are surrounding the engine, okay? The engine is also the STEM technology, so the engine is precisely positioned right over there, so we are surrounding the engine and to see the whole view of the engine. So you could directly change the different angle. Okay, like here we have a 12 angle, so you could select it differently. Okay, so next please. Okay, and here is we use a game engine. Okay, that means learning based on processing content generation. This is also what you call it right now. It's called the AI. Okay, we use a very easier way. Okay, the game engine and the progressive-based content generation. So when we have a manufacturer, we want to modify that mean different parts. Okay, so we could assembling or modify the parts and took this virtual car. Okay, using the virtual track. Okay, so we could simulate the modification or the design is suitable for the real or not. Okay, so we get the CAN box information from the real car and implement inside the virtual world and do the test run. Okay, so when we modification and they still could follow, is there anything we got to change it before we implement inside the real car? Okay, next please. Okay, for the security, we also have a ICEBSH Innovation Mixed Reality Tech Platform developing. Okay, next. Okay, and here is we have in the Saron Cybersecurity Hub. Okay, we work with E3 and we build out the virtual. Here is on the Saron Cybersecurity Hub. They have a simulation of the pipeline here, and we build a virtual pipeline. Okay, so they could simulate how if a hacker use USB or internet hack into the system and they automatically visualize along the system. Okay, so they know the hacker is getting inside the system and they shut down the machine, shut down the progress. Okay, next please. Okay, and also have a roundtable conference provided by the Taida University of Professor Chen, and on the talk will be have a Meta and a Microsoft and the E3. Okay, next. And here is a Japanese company from Shomben. Okay, they come to our school, our lab, okay, to discussion with how to use a HoloLens to do the manufacture, maintenance, and the assembling of the machine. Okay, next, please. Okay, and from the smart tutoring here, next, we have a, okay, please, please. Okay, we have the IG World Sports and the Tokyo Olympic Game. We have a partial of an opportunity to participate and join the project with the Japanese company. Okay, next please. Okay, and here is, I think right now there's most of the demonstrate the R&D base for the amending of a mending machine. Okay, right now you could on the mending machine on the Taiwan, okay, around Taiwan area, okay, most of them will be developing, cooperate with the industry company and really have commercial product, okay, it's on the market. Okay, next please. And here is for the camper tour system, also use a VR system here and combine with the Google Map, okay, so you could locate the position, and even you not been there, you could directly go to a library and they go your virtual touring of the library. Next please. And here is we work with order about this. I mean, that's a assembling furniture company. Okay, we build out the virtual design center and designed it. You could directly use those kind of the engineer put inside the virtual and real way together. So when you go to the order about to purchase the furniture, okay, you select the furniture, and after that they print out the picture. Okay, directly print out picture and print out the price. Okay, and when they deliver, they go inside your house and they just follow the picture and put in the order. Okay, use the AR technology. So in here we show our virtual and real integration will be in the furniture error will be in the 1 millimeter. Okay, so they mean they give us a lot of perspective. And this one also, if you are interested in the IKEA's, okay, the IKEA, the catalog also have the marker. Okay, so the marker, you scan the marker, they could bring the virtual furniture, because IKEA right now, they're developing their furniture with a 3D, okay, model. Okay, so next please. Okay, and here is for the virtual housing fusion. Okay, in here is, please stand here. This is the first example. We have an interchange with the VR and the AR mode. Okay, like here you will see that's AR mode. So the AR mode, when you move in it, you could surround in the house to see that. Okay, when you close it, we enlarge the picture. Okay, enlarge the image, and you far away and they will shrink the image, because the AR technology with the distance. Okay, the VR without the distance. So after that, we also to enter the house to become the VR mode. Okay, and because of VR mode, we bring in the surrounding of the panorama image. Okay, so like a lot of people were interested of the feng shui. Okay, so they could real the environment, and after that maybe do the slight change. Okay, or modify of the house position. Okay, so okay, probably need another second, and we go into a VR mode. Okay, right now we get into a VR mode, so they bring the panorama of the vision. Okay, so they could see. Okay, and that means you could change the angle or change the window position or door position. Okay, precisely. Okay, next please. Okay, and here is for the eye weighting of the checklist. Okay, in here will be for the EDM. Okay, and after that we also build a one-to-one of the glass. Okay, so here is for the virtual fitting. Okay, here will be embodied inside the fast track technology, and after that they bring in the virtual of the glass. Okay, so you could change a different type of glass. Okay, without wearing it. Okay, and also we have because we have mentioned that we have 2D convert retop to the 3D technology, so the fitting you when you turn in your face, okay, they still very smoothly. Okay, that without of the tracking. Okay, so next please. Okay. And here we are in the Taiwan Pacific Museum. Okay, we have a present a whole system of the represented. And most important is we have a server, so that all the content will be directly changed from the server. Okay, so they could change the platform. Okay, the edition hall. Okay, the edition they could change by the server on the back end. Okay, and they directly change it. So you could change your expression very frequently, or depend on what you need, and you have a modification application. Okay, next please. Okay, and here is in the Taichung interconnectical of the baseball student. Okay, in here, please here. Okay, here just to have we are very honored we have opportunity to get inside this student. Okay, on the pitch. Okay. So here we have a pitch to take the panorama of the view of the student. Okay. Okay, here is the pitch. Okay, we pitch different type of the ball, and we want the captures more. Okay, so when they wear the vibe, okay, or this kind of the goggle or the virtual reality device, okay, they could have an experiment about what the face or what the curveball is, or what the fastball, okay, different type of ball, and they could have those kind of experience from the catchers more. Okay, so next please. Okay, okay. So during this application, okay, we are trying to push the boundary of the virtual and physical system in training, manufacture, service, or even for the interactive experience. Okay, and we are very delighted or involved or excited to keep it driving innovation and welcome future cooperation opportunity. Okay, thank you for your attention. Thank you.
Okay. Okay, we are very much thank you, Professor. Okay. Professor Zhuang, please have a seat. Okay. Thank you so much for your profound interest in and amazing talk about the virtual AI training and the role of listening in education. I think they talk about the experience, especially the combined with the virtual and the real integration experience on another industry, especially for the airline industry, and also car industry, and also talking about the IKEA, right? IKEA furniture industry. So I think the AI or VR or AR technology is kind of our daily life. So I think this is all about our experience. So now we are open for questions from audience. So if you have any comments, questions, any viewpoints, please raise your hand. We will pass the microphone to you. Anyone? Okay, I think as I know, our students, they using the ChatGPT to write in your thesis and your homeworks, right? So I'm not sure this kind of experience, okay, are going to against your learning or experience. So anyone want to share about your experience? Okay, I have one question. Okay, I have to prepare one question at least. Okay, my question is: you emphasize the listening and hearing. Okay, in the future education, how does that connect to sustainable education practice? Because we're talking about sustainable development, right? Do you have any suggestion? Because we from different major background, right? Sounds very interesting to apply the technology to the engineering school. Okay, so do you have any suggestion? You know, how to use the education practice in a different department or different school?
I think that's ChatGPT come out, right? So you are not expert, okay, but you also, like the code we have write, okay, we use ChatGPT to rewriting for us. They have a 85%, 80 to 85% accuracy, okay? So that means we modified it. Right now we use the ChatGPT to write a code for us first, and after we modify it, okay? And shrink our time. In the beginning, maybe we like one of the amending machine source code, the partial, we spend maybe 1 month doing that. But after that, we use ChatGPT, we do writing it, take up probably 1 week to do that. Okay. So that means even we are now, that's why I say in the beginning, you need to know how to write a code. That means that's knowledge. Okay. But right now, you only need to know. That means the ChatGPT, you know the logical or know the real procedure, and very easy, okay, to use this kind of modern technology and to help you or assist you to do your work, okay? And that's why we got to learn. And even later on, okay, because you still need to know that, right? You know, like ChatGPT, you need to know how to ask the question. But when you're hearing, that means even you don't know, you don't need to know how to ask question, because the AI will be listening all your talk, okay? And after that, they knew what you need and provide your suggestion and tell you, okay, you could do that, you could do that, okay? Even you didn't need to know, okay? Because the AI, they tell you what you got to do, okay? But there's probably in the near future, we can see those kind of technology be developing, because right now, a lot of Siri or Google will be background listening what we are talking. Okay, they are still continue listening. Okay, even we talk about the hi Siri or hi Google, and they wake up. Okay, but that means they will start to listening. But during those kind, they still background still listening what we are talking. So they will continue monitoring. Okay, what we are doing. Okay, so yeah.
Okay. Okay, thank you so much. Any comments? You know, I'm just worrying about the AI is going to replace the teachers in the future very soon, okay? Because, the students that, they just put their assignment homework to the ChatGPT. And then as a teacher, we don't know this is the right answer from the student or not, So that's very, I think that's a problem in the future. We'll have to think about it. Okay. Any question?
Yeah, so I would suggest you want to use a ChatGPT, you must use it smartly, okay? Because sometimes you actually, all your colleagues give you the same kind of answer. That means you work dumb, okay? So try to use the ChatGPT smartly.
Okay. Okay, there's a question. Okay. Okay. Yeah.
Yeah, good morning, Professor Chang. I'm Nikki from Tarumanagara University. I'm also a lecturer from interior design. I'm just wondering, is that any AI for Feng Shui? And because I met several clients, usually in office. Like I already set the design, the layout, and already produced the furniture, and then the Feng Shui expert came. And then we have to change a bit because adjusting with the Feng Shui. Is that possible if we start together adjusting like each room dedicated to a person biodata, let's say? Because Feng Shui, there's a calculation.
Yes.
So it's easier for us interior designer to calculate. So let's say this room have to side by side with this person because the zodiac or the birth date, let's say. Have you ever know about this? Because you showing about the layout.
The layout.
Yeah. The architecture.
Yes.
Architecture,
Yeah, I just think about that. Yeah.
Yeah, it's possible. Yeah.
Is there any application about Feng Shui?
What we have done is for like when you read for the AR mode, right? Like for the furniture you want to put inside the housing, okay? Because we implement the AR mode, so they have a distance already. So you rearrange, okay? And it's okay. So you could arrange it virtually, okay? Yeah. Before you ready to manufacture it or produce it, okay? You could virtually, like for the virtual colors, mean we want to modify all the virtual colors, mean you're not ready to make the car yet, but because you have physical data, right? So you implement the physical data to do the virtual testing run, okay? And make sure it's okay. And after they produce, will be similar to previous we call the simulation. Usually we have simulation program. But right now it's a virtual simulation. So also the mutual simulation, but at that time they don't talk about virtual, they just talk about simulation. Okay, but right now they have AI, they have virtual reality, augmented reality, so they try to talk about the virtual simulation, but there's still simulation. Okay. For that means we have a working for I think not really. If you are interested, we could talk about later on, okay? Maybe more detail of the specific, and I know what you need, and maybe I'll give you some suggestion related to this kind of the research, okay?
Okay, thank you for your questions. Okay, Professor Zhuang is expert in the media arts and high-tech technology applied. Okay, so you can ask him later. Okay, thank you so much. Thank you, Professor Zhuang. Thank you for your outstanding speech. Any question? Okay.
Thank you.
Thank you. Let's give him a big hand applause. Thank you. Now we are going to invite the next guest speaker, Professor Zhang Chun Kit. Please give you a big hand. Welcome, Professor Zhang Chun Kit. Give you a big hand, applause. Okay, he's over there. I want to introduce Professor Zhang Chun Kit. He's an accomplished associate professor and director of postgraduate study at INTI International University, Malaysia, with a PhD in mechanical engineering from University Sydney, Malaysia, and a strong background in applied mechanics, biomechanics, and art, of course, AI, artificial intelligence. Dr. Zhang amplifies interdisciplinary innovation in engineering, education, and research. Please welcome Dr. Zhang Chun Kit. Okay.
All right, good morning, ladies and gentlemen. First of all, thank you, Dr. Oscar Lee, for the very great introductions about myself. Can you just share my slide? Okay. Yeah, this is the topic of my presentations today. It's about integrating AI for sustainable human-robot interactions. So I'm also talk about AI, but in different applications. So let's move forward next. Yeah, this is a little bit background of my, since Dr. Oscar Lee has explained about my background, so I think I just skip for this. Let's go to the next slide. Yeah, so when we talk about sustainable development, we will think about SDG goals. So actually there are 17 SDG goals that come up by United Nations. So my research is more focused on the SDG 7, affordable and clean energies, where actually I'm involving into the research of electric vehicles, which is used for the thermal management of the battery. And this could be applied for the solar energy as well. So I think you heard about solar panels. So actually AI can be applied in solar panel as well to adjust the angle of tilt based on the environments that the solar panel is going to install, or the angle of orientations of the solar panels could be applied also. And also the next SDG goals that my research focus is on SDG 9, which is industry, innovation, and infrastructures. So this will be focused more on the robotics design, where I can actually incorporate AIs into robotic design as well. So let's move forward. So let's play the video. Yeah, this is one of the videos from Pacific Rims. I think you have watched this video before. So the concept for this video is that there are actually some humans in the robot, and they can actually control the robot with the humans inside. So as you can see that here, there are quite many humans inside. They actually come out with some neural brains signals and they used to control the robots. So my research is actually come from this movie as well. Let's move forward to the next slide. So let's talk about the overview of the human-robot interactions. Human-robot interactions involve quite many disciplines. It's not just only mechanical engineering, but it's also cross-disciplines research. It does involve about artificial intelligence, neuroscience, biology, ergonomics, because it talks about the designs of different arms, for example, the legs and also the robotic arms. So it does involve about different applications. Evolutions of HRR, human-robot interactions, reflect the shift from a robot performing the repetitive tasks, because some of the tasks that you require the robot to do it repeatedly, that we can actually use AIs to let it to perform the task, and it can actually use to reduce the labor work as well. Next, please. So AI will be served as a backbone of HRI. I think you heard about artificial intelligence, and as what discussed by Professor Chuang and Dr. Oscar just now, ChatGPT. So ChatGPT is what we call as a generative AI. It's actually the subset of AI. It's different compared to AI is that generative AI, it tends to create a new content. That's why when you ask ChatGPT to come up with the prompts, please help me to write a thesis, it can come out a lot of things. But AI is different. AI is actually works based on the input of the data, which means that you give the data to the AI, and it will help you to analyze and produce the output that you want. So it's different compared to generative AI. So yeah, generative AI is quite common nowadays. You also heard about DeepSeek, Gemini, the different generative AI accounts that you can hope to come up with different outputs. So for my research, I take AI as a backbone. So because AI can help me to analyze the data, help me to collect the data, to pre-process the data, and to come out the output that I want. So the key technologies that involve here will be the machine learning. For example, for the pattern recognitions. For the pattern recognitions, it does involve about computer visions. For example, in the industries of Chinese herbs, we want to recognize what types of species for the Chinese herbs. Perhaps you can use AI, machine learning, computer visions help us to recognize. Because as an ordinary people, you don't actually recognize what kind of herbs is this. Is it a dangui? Is it rensen? If you are not the Chinese herbal expert, we don't actually recognize the herbs. So, but when we're using AI, computer visions, machine learnings, we can let the computers to learn and then let it to recognize the herbs automatically. All right, please move on to the next slide. So AI is not just only like what I taught just now, but also able to enhance communications and collaborations. Because AR, it can be applied in different applications. As I said just now, it can be applied in the manufacturing industries. It can be applied in the medical industry as well. So AI empowers robots with the abilities to interpret the human language because it can analyze what the message is represent about just by doing some analysis, some classifications, some predictions of the modeling. So for instance, for the sentiment analysis algorithm, it can help the robots to understand human emotions. For example, if you want a robot to understand how the emotions or the expressions of when you're playing with the people, you can actually use a robot here to recognize your expressions and then to read it automatically. In a sector like manufacturing and healthcare, collaborative robots is the ones that most commonly used, or we call it as a cobot. So it works along with the human. It assists the humans in performing some of the tasks. For example, when you want to repair cars and you want to find out apparatus to repair, you can just use a voice recognition to ask the robots to give you some apparatus that require to repair the car. So that is what we call as a cobot. So robots can help us to do some tasks in a hazardous environment. For example, in power engines industries, it does requires robots help you to perform some difficult tasks, some dangerous tasks. So it hereby enhancing the productivities and the safety of the working environment. Let's move on. So AI's personalized and adaptations, because AI, it can be trained to just work for an individuals, because different individuals have the different requirements and desires. So AI can be actually trained to actually work as what you want. Here, let's say you want the AIs to work to come out with the master thesis or master degree project. You can actually ask it to come out with that particular thesis just by giving a clear instructions on what to do. So robots equipped with the adaptive learning capabilities can also do the same things. You teach a robot on what to do when they face some tasks or some environments, it will actually redact it automatically so that it can perform the task that you want. So yeah, that is another applications that robots can be used for personalizations and adaptations. Let's move on. So let me share you about one of the research that has been done in China. So they call it EEG embedded system for feeding monkeys. So as you can see like here, there is an embedded system of EEG. So they actually embedded the sensors inside the brain, and then they collect the data based on the nerve. So you can see the sensor is actually inserted into the nerve and how it receives the brain signal data. But the way that they conduct the research is quite, some people will say quite unethically, because what they do is that they tie the monkey's hand and then they put the food in front of the monkey. So they actually create or trigger the desires of the monkeys to hunt for the food. And then they will collect the EEG data, the brainwave data, because when the monkey think about the food, there will be some signals that come out from their brains, which is called the EEG data. And they collect these data to help them to decide on the mechanical arm, so that the monkey have the desire to grab the food in front of him. So that's how they actually collect the data. But this approach haven't been applied in human yet. They're still in the research stage. Let's move forward. So of course, there are some challenges and ethical considerations. As I mentioned just now, implements AI in HRIs. It does involve about moral and ethical adjustment. Because when you want to collect data, since it involves humans, when you want to collect the brainwave data, it does involve about some privacy. You need to get as a consent from the patients or from the subjects that you want to collect the data, so that this data will be kept in a safety environment. It's not going to share to the public. Public won't be knows about your EEG data. So there's the approach that we want to consider about. Of course, some of the things that we can use a secure AI algorithms, which is actually to secure the data when we actually collect the data from the humans or from the subject. Let's move forward. So this is a schematic diagram of the sensors that installed in the EEG cap. The right-hand side diagram right here is following the international standard of the EEG electrode. The left-hand side is the device that I'm using. I'm actually using the device from Emotive. Emotive is one of the suppliers for the EEG cap. And the sensors that I'm using, there are 32 sensors. So compared to the one at the right side here, which is about 20 sensors, the one that I'm using at 32, which will be able to collect more data. Let's move forward. So I just share you about the flowcharts of entire research by EEG research. There are 3 stages here. The first stage is about data acquisitions, which is used to collect the data. As you can see here, when I start set up here, I need to do some calibrations. The calibrations will be required for the accuracies of the data they're going to collect. And of course, the quality also. If the quality is not acceptable, I have to do it, we adjust again, calibrate again. And then it go to the mentor command trainings. And mentor command trainings is one of the trainings that embedded in the emotive software itself. Which means that before I collect the data, I have to train the subjects, train the persons that are going to collect the data, so that it's going to focus before we collect the data. So then, if the emotive is able to recognize the commands, then yes, we can move forward to the next stage, which is to collect the data. If not, then we have to redo the training again, so that the trainings that we do is actually meet the requirement. So once it meets the requirement, we go to the next stage, which is to collect the EEG data. And that EEG data come out is very huge, very large data it's going to collect. That's why I need to do some data analysis. For the data analysis here, first we need to do a data pre-processing. We have to pre-process the data so that the data will be able to use later on for the analysis purpose. So what we need to test here is that is quality is going to accept or not after the pre-process. If the pre-processed data is acceptable, then we can move on to the next stage. If not, then we have to go back to the data pre-processing stage again. So when it is okay, we move to the next stage, which is the feature extractions and selections. The feature extractions and selections are here. Here's the process that we actually identify what is the region of interest of the EEG data. And then we have to select it and extract it. And next, we have to choose the classification model. There are a lot of classification models. Maybe you've heard about artificial neural networks, heard about decision trees, forest randoms. So there is actually some of the classifications model that's available. So we have to choose the proper classification models, and we use a classification model here to do the recognitions. So recognitions that I said here is 76%, because this is based on the previous research. So they said at least 76% of the accuracy. If it is able to accept the accuracy of 76%, then yes, we go to the next stage. If not, then we have to adjust the model again. So for the next stage here, we will to do the programming. The programming here, I'm using a Python programming language, which is used to program the robotic arms based on the data that received from a EEG cap. So for the programming part here, I involve about Arduino microcontroller. So this is one of the microcontroller. Arduino is one of that. Raspberry is another one. So I'm using Arduino. And this Arduino will be able to send the instructions to the robotic arm so that robotic arm will be moved according to the EEG cap data they're going to receive from the microcontroller. So that will be the end of how the entire research. Let's move forward. The sample size that I'm using is 6 healthy subjects from my university. So basically, it's actually the students from 18 to 26 years old, 3 male and 3 females, because I have to make sure that the data that I'm collecting is going to standard. It can be applied for both male and female. So one of the research that done by Jari 2015, highlight that male demonstrate a superior control and efficiency compared to females. So one of the reasons is that because when we want to collect data for the female hair is longer and more compared to male. That's why we want to wear the EEG caps. The head itself is actually blocked the sensor. So it's hard for us to do the calibrations. For the calibrations for females, it require more time compared to male because of the hair they're blocking. Okay. Next, please. So this is a demonstration of how I collect the data. Please play the video for a while. So this is one of the subjects here. So in front of the subject here is an emotive software. So whenever a subject is performing the motions, you can see the software here actually recording the EEG sensor. There are actually 32 sensors that are moving. So when the subject here moving the arms here, some of the sensors you can see a sparklings of the signals. So that means that there is a sensor that come out with the signal to control the arms. And we actually choose that particular signals here to pre-process again, classifies, and then sends instructions to the microcontroller so that it can send instructions to the robotic arms to perform some motions. Let's move forward. Yeah, this is a mental command trainings that in emotive software. So you can see that here there are different motions here: lift, drop, rotate clockwise, push, neutral. So when you wear the EEG cap like here, there's actually one interface here, let you to train your brain. For example, if you think to lift the dot, you can see the dot like here is going to lift. When you think to drop, then you can see the drop here is going, the dot here is going to drop. So before we collect the data, we need the subjects to perform this mental command trainings so that the brain with data or EEG data that they're going to collect will be consistent later on. So the next, please. So yeah, this is a set of the EEG raw data that's going to collect from the emotive software. So as you can see, like here, there are different labels: CZ, FP1, FZ. These are actually the locations of the sensors in the EEG caps. And you can see that actually the frequencies that are going to come out. And few of the frequencies like here, the orange, green, the blue, and the purple, you can see this is a sparkling of the signals. So maybe that is an instance or the particular sensor like here going to come out with the sensor when we actually move the arms here. And we actually focus on that particular part to do the further processing. Next, please. So this is how for us to do the data pre-processing. This is a bunch of the data that we collect from the EEG data just now. So we convert it into the CSV format, and we identify what are the region of interest, which is highlighted in the yellows, and then we do the programming here, let us pre-process the results. The left-hand side is the one that before, the right-hand side is the one that after the pre-processed data. And we're going to use this bunch of data here later on for the classifications. Next, please. So this is the feature extractions and selections process from the left-hand side here. The feature extractions are by the emotive software. So actually, they are the feature extractions methods that are available in the emotive software itself. So we can actually choose the feature extractions methods that in the software itself and to perform it. And after that, we have to use another software here, which we call WebCar. WebCar is one of the data mining software that here help us to classify the data. So this is one of the processes here we use to select attributes here to classify the data. Next, please. So yeah, classification model that we are using here, actually we're focusing on the random forest. We have so many classifications model that here that use in the research, but we found that random forest is when they come up with a higher accuracy. Move on, please. So for random forest here, they achieve 95% of the classification accuracy compared to the rest of the classification model here. Because this data will be able to learn and predict a new data set faster compared to the rest, and the robust to the noise data, which means that if the raw data is come out with inconsistent, so random forest here will be able to classify it accurately. So we use training data and test data options here to do the classifications. So this diagram is just showing you how the random forest is going to work. And you can see that here there are different trees here. Tree 1, tree 2, until tree n. N here is actually the number of the input trees that we are actually using. Move on, please. So this is the diagram that's showing the fabrications and the circuit connections. So this is Arduino board here, and then we use several modules here, uses control with the robotic arms, so that when these microcontrollers Arduino receive the data, you will be able to send instructions to the robotic arms to perform a specific motions. Move on, please. Yeah, this is how the actual product in the research. Yeah, this is the Arduino board, and this is a robotic arms that we are using. You can see that actually cables here we're going to connect between the board and the arms, so it can perform motions. Next, please. So yeah, this is the videos. Let's play the video for a while. So you can see that here the robot is able to perform the motions and grab the objects in front and then lift it. And you can see the laptop behind there is how the back end data is going to perform when we do the analysis. So this research is still in a preliminary stage. It's not going to apply for the patients yet, but I think that we need to more times to do some research, train more data before we can apply it for the real humans. Right, next, please. Yeah, so my research has ended for the presentations. So this slide is just promoting some of the further study opportunity because as a director for the Center of Postgraduate Studies, from Indy International University, we just provide a scholarship for international students to pursue a master or PhD degree. As you can see like here, there are two schemes like here for master degrees. We provide 100% tuition fees waivers, but there are certain requirements. You have to publish 2 Scopus journals. For the scheme 2 like here, 100% waived, including miscellaneous fees, which is like visa application fees, accommodation fees, and so on. But the requirement will be higher. You have to publish 5 papers. For PhD, scheme 1 publish 3 papers, scheme 2 publish 10 papers, so that you can exempt it for all the fees, including tuition fees and miscellaneous fees. So if you're interested, you can contact me via the email here, chuanye.chen@newindy.edu.my. Next, please. So last but not least, if you're interested in my research and you want to do collaborations with me, please scan the QR code here so that we can have further collaborations on my research. Thank you very much.
Okay. Thank you so much for Professor Zhang Kun-kit. Please have a seat. Okay. Who is very interesting, I think also very professional speech on how artificial intelligence can enhance the system of human-robot interaction. Okay. Due to the time constraint, only one question, very important question. Okay. From the audience. So, Professor Zhuang, do you want to? Okay.
It's very impressive your study, okay? We also have to do some EEG relate to the ice tracking, okay? But we just for the fundamental basic research for just for the emotion, look at the picture, different direction, and those kind of stuff. But you are very impressive for your research. Thank you.
Thank you so much.
Okay. I have questions. Okay. For the Professor Zhang Kun-kit, what's the biggest challenges in designing AI systems that align with the human values in sustainability context?
The biggest challenge that I first received would be to collect the data itself because it requires calibrations. Once the data is being collected, we need to do some further processing, which by using the AI algorithms. And I found there's different persons, even male and female, they think differently. We know that when you're married, you know, right? So your wife thinks differently. So yeah, that is a reason that this is one of the challenges in Institute. And algorithm, we have to work consistently, not only for male, but also for the female as well. That's why the training process of the AI itself is another challenging part. Yes.
Okay, thank you so much. Everyone is unique. Also, we have to consider the ethic issues, problems. You cannot put an ending system for feeding monkey. Looks very okay. Okay, thank you so much. Thank you. Let's give Professor Zhang Kun-kit a big hand. Thank you so much. Very professional perspective. Okay, the last guest speaker, we are going to invite Professor Ariwan Gunadi. Okay, let's welcome, give him a big hand. Professor Ariwan Gunadi. Okay, Professor Ariwan Gunadi, distinguished legal scholar. Please help over there. Legal scholar in Indonesia, youngest professor in business law, and appointed to be the just 38 years old, a graduate of University Hongta. He earned his doctor with law from University Indonesia with cum laude honors at the age of 27, very young. Okay, become the youngest to do so. He's expert for his international law and the business law. Okay, that's welcome the Professor Ariwan Gunadi. Okay, thank you.
Okay, thank you very much, moderator. First of all, I would like to welcome to the honored the host for today, especially from Kunsan, Associate Professor Chang, Professor Mark, and also all the delegation and the students from Kunsan University. It's been 3 times, I think, to be here in Kunsan, and we're glad to have cooperation between Tarumanegara University and Kunsan University. And also, today, there will be also delegation from INTI Malaysia, and in the opening, a few days ago, I heard many of delegations from several universities from other country. From Universitas Tarumanegara, of course, our rector, Professor Ahmad Sudiro, Dr. Hetty, Dr. Didi, Dr. Mei, and all the delegations from Tarumanegara University, our colleague, Mr. Roy, from German, and also the students from Tarumanegara University. First of all, my name is Aryawan Gunadi. My current position as the chairman of Tarumanegara Foundation. Our foundations, we have several units under the foundation in Indonesia, like Tarumanegara University. We have institutes, and also we have several schools, hospitals. I think Dr. Linda, once you came to Indonesia, and many times to Indonesia, you see some development in Tarumanegara. So hopefully, all the students and this conference one day may visit us doing such kind of student exchange, lecture exchange, and some of the delegation may come to us. Thank you very much. Okay, the committee asked me to deliver a keynote speech. So in 15 to 20 minutes, I would like to deliver our remarks, our ideas, especially on this conference, ICASTE and ICBSH. And of course, these collaborations raise the issue of accelerating global sustainable development through higher educations. And this is a very challenging issue in nowadays. Okay, it's profound honor to join you today to this international platform under the timely of transformative theme, the accelerating global sustainable development through higher educations. And at the time, compounding global crisis, climate disruptions, widening inequality, geopolitical uncertainty, we know that today, tariff imposed by Donald Trump to several countries, especially to China. Indonesia, we get tariff also around 32%, and now they gave 3 months for renegotiation for the tariff until the next 3 months. I think Taiwan too, we face the same situations, but we believe from the trade war between US and China, everything will be going well, and hopefully there will be a good diplomatic issue that's been challenging and that's been negotiated by both countries. And we know that in higher education must shift from being a passive observer of global challenges to becoming a co-architect of solutions that transcends borders. So this is the role of higher educations. And also in 2015, the UN adopted the 2030 Agenda for Sustainable Development comprising 17 Sustainable Development Goals. I went to UN in Geneva with Mr. Roy on last year, right? And we are discussing many times, many things about the SDGs. And this is goals from a blueprint from peace, prosperity, and planetary well-being. So it's not only 5 years remaining, we are dangerously off track. And of course, based on the 2024 SDG Progress Report, only 50% of targets are on course to be met by 2030, while nearly 50% remain moderately or severely off track. This is not just a call for government of corporations, but this is a call for us, this is the job for us, for higher educations, leaders, educators, and students to take ownership of this global mandate. And higher educations hold unique power to influence every SDGs. I think from President Lee from Kunsan, and also our universities also concerned on that. and not through isolated research or advocacy, but through integrated action across teaching, research, operation, and community engagement. Globally, university are being to internalize sustainability as both an ethos and a strategic directions, but progress remain uneven, and we know that we have to consider some institutions paving the way. If we take the example from Arizona State University that mandates sustainability educations for all incoming students and hosts a cross-disciplinary carbon innovation lab. If we see University of Toronto integrates SDG-aligned performance into tenure evaluations and institutional planning. And from NUS, our neighbors from NUS Singapore, National University of Singapore, is developing green finance and climate tech accelerators supporting both research and entrepreneurship. So entrepreneur is also the backbone of the universities. So to make meaningful progress, university must activate 4 strategic pillars. First one is curriculum innovation for SDGs. Every graduate must be SDG literate. This involves climate justice, inclusive growth, and ESG thinking into engineering, law, health, and business educations. Second one is research with transnational value. Academic research should move from publications to problem solving. Universities should prioritize climate adaptations, energy transitions, system and urban resolutions as focal areas aligned with national and regional development agenda. Third one, that the operational leadership, for example, university must reduce their own environmental footprints through campus decarbonization. I think this is concern from the Taiwan. And sustainable infrastructure, institutional modeling creates credibility and trust. Fourth is global and local partnership, and through North-South and South collaboration, university can exchange model. I think what we have to collaborate between Kunsan and UNTAR, and co-create solution and contribute to global policy goods, and partnership with local communities ensure SDG efforts are grounded and equitable. So we need to train professionals that may design climate smart infrastructure. This is very important. Maybe some of you from the planning or from the engineering faculty. Advice on carbon market participations. Lead sustainability reporting in businesses, maybe from the faculty of business. Integrate social and governance metrics into investment decisions. And this is the future of global trade. And finance and governance will be shaped not just by technological innovations, because we know that AI is very growing fast now, but by institutional and regulatory readiness, our students must be prepared to lead in both areas, so between the technology and another sectors. To accelerate SDG implementation, university must deepen their involvement in global alliance that foster knowledge exchange, capacity building, and shared governance, that initiatives such as University Climate Change Coalitions. In Tarumanegara, last time we have a climate adaptive laboratory. We also support for the development of human cell laboratory, which have collaborations with the lab from Geneva in Swiss. And also multi-stakeholder coalitions linking academia, industry, and government. This is very important to collaborate with them. And then, in addition, allow me to share a few initiatives from the Universitas Tarumanegara or Tarumanegara University in Jakarta in Indonesia. First is circular economy practice. Through our e-waste donation program, students and faculty collaborate to manage electronic waste responsibility. Second was inclusive innovations. We did it. Research on prosthetic using bamboo and rattan has led to low-cost sustainable healthcare solution aligned with SDG 3 and SDG 9. The third one is cross-border collaborations with several universities in Malaysia, in Kunsan, Taiwan, Our students co-develop sustainable design projects that merge cultural insight with global standards. The fourth one is curricular transformation, sustainability principle infused into courses like sustainable logistics and green operation makes SDG awareness a life experience. On the other side, digital technologies have become indispensable tools for scaling sustainable development. AI, as I mentioned before, blockchain, and big data analysis are being deployed by top-tier universities to track emissions, map biodiversity loss, optimize resource use, and misinformations of climate change. University must evolve the internal governance to perform frameworks to reflect a commitment to long-term societal impact. This includes reforming tenure and promotion system to reward interdisciplinary, community engaged, and policy-driven research. And with metrics with SDG contributions, this is also important. And we have to realize that the transforming role of higher education requires unblocking new financing models that support SDG integrations. And the university example, the University Tokyo, maybe some of you know in Japan, has established a green finance lab that connects financial regulators, students, and investors to structure climate related financial products. And higher education institutions must now act as both knowledge providers and financial innovators. To further solidify how our higher education's role in sustainable development, university must embrace the concept of impact ecosystem. I think we have to underline this. Collaborative environments where policymakers, industry, civil society, and academia co-create solutions. Impact ecosystems, this is also required not only academic input, but also real-world testing grounds. And equally important is the emphasis of inclusivity and equitability access to sustainable educations, institutions, and this must prioritize scholarship program for sure. Transformational learning pathways and digital platform that enable underserved and remote communities to engage with the SDGs. So the role of lifelong learning also cannot be overstated as industry transitions to greener economics, upskilling and reskilling of the existing workforce become vital. University must lead the process through open access educations. I think this is what Kunsan did. Micro-credential and executive program focus on climate adaptations, ESG governance, and digital sustainability. This effort ensure that education be sustainable development age, background, and professional stage. Finally, the future of global sustainable development will bring not only on technological innovations, but also on moral leadership, so that we have to also concern. University must cultivate values of empathy, responsibility, and global citizenship in every students. And as an educator and scholars, our duty is not only to inform minds, but to transform perspective. And we stand to the turning point that the choices we make today in classroom, boardroom, and policy forum will shape the legacy of this century. So we must elevate higher education from a vessel of knowledge to a vehicle of global transformations to do so. So let us embrace SDGs as the mission, not the margin of academic life. Let us move from silos to system, from compliance to creativity. Let us reaffirm our role not just educators, but stewards of global commons. Together we have the power to turn this decade and opportunity into decade of actions. Let us ensure that our institutions do not simply teach sustainability, but let it and leave a lasting mark. So lastly, I think thank you very much for Kunsan for this cooperation. It's been an honor to be here. I think this is the third time to be here. And hopefully this few days conference will be a success, and success for all the students, and also good luck for all the scholars, teachers, and for all of you. Thank you very much, and God bless you all. Thank you.
Thank you very much for Dr. Ariana. Could I please stay on the stage because we are going to give the thank you certificate from the Kunsan University Director Mark Lu. We also would like to invite Rector of WUNTA, Professor Aman Studio, to give the application for the Professor Dr. Chen Lin Zhang. Thank you so much for Rector's Aman Studio. And then we would like to invite Dr. Haiti to give the application to Dr. Chen Chong Kit. Please be on the stage. We would also like to invite the chairman of the committee, Dr. Didi, to give the application to Dr. Oscar Lee. Ladies and gentlemen, today's conference is a special occasion with the participation of scholars from far and wide. We would like to invite you all to join us for a photo session to capture memories of the gathering. First of all, I would like to invite all the honored guests on the stage and our keynote speaker. Let's have a group photo first. On the stage, please. Next, please have photo group with the student. Please be seated. Student, please gathering in the center so it's easier to have the group photo. And please all stand up. Please, everybody stand up. We are going to take the stand up photo. Thank you. 大家站起来一起拍照，因为他们还有很多线上的贵宾，所以希望能够看到大家。请两边同学可不可以往中间集中？还有我们林老师可不可以来前面？那个我们教授可不可以往前面2排？还有我们陈教授，还有庄教授，昆山老师可以来前2排吗？
大家请往前面集中好不好？然后我们往中间，对，这样子拍太旁边了，我会看不到你们，而且我会变胖哦。好 ，OK， 好，好，大家我看，我们先拍第1张，1、2、3 ，OK， 再1张，好，然后接下来要再做一样手势吗？不用 ，OK， 好，那我们大概就今天的。
We would like to thank you for all the of the organization community and the staff members who have worked very hard for this wonderful conference. And for students online, please get the link and fill in the questionnaire. Okay, thank you very much. I would like to give my best thank you, appreciation for all the honored guests. We will also invite you to join for the lunch on the International Conference Hall at the library, 10th floor. Looking forward to continue our discussion in the afternoon after a delicious lunch. Thank you very much for your joining today. Yeah. 那现场的同学，请帮我扫这个条码。扫完条码之后，填完再散会。谢谢大家。